Today we are talking about the sine law and doing some trigonometry where we are trying to solve the sides, missing sides or angles in a triangle. Now generally speaking, a triangle has 6 pieces of information, right? If you know 6 things, then you know everything you could possibly know about the triangle. There are 3 angles, A, B, and C, and there are 3 sides, A, B, okay, it wants to capitalize them. A, B, and C, which again do not have capitals. A is across from angle A, B is across from angle B, and C is across from angle C. So it would look, something like A, B, C, and polygon A, B, C. And you can see how it draws it. It draws the different sides across from the angle that they're related to. Now, in general, okay, if you know 3 pieces of information, you know enough to solve the triangle. So, depending on what you know, you need to use different strategies. But in general, if you know 3 pieces of information, you can solve the triangle as long as the information you know is not 3 angles. So let's just write this down quickly. So any triangle in which you know 3 pieces of information is solvable as long as those 3 pieces are not all angles. Okay? So let's try this one. So that's just generally like a little introduction to what we're doing. Let's try the first one that we have. So it says they're part of a team. Part of a scientific team studying thunderclouds. The team is about to launch a weather balloon. Albert's rope is 7.8 meters long, makes an angle of 36 with the ground. Bell's rope is 5.9 meters long. How could you determine how far one is from the other? So let's draw this. Okay, so let's put Albert here at 0, 0. His rope, we said, was 7.8 meters long. So we'll draw a circle, 7.8. We'll go 7.80 would be the sort of ground, and we'll rotate that point B, what did it say, 38 degrees, I think? 36 degrees, sorry. So 36 degrees. And here is Albert's rope, right? And we'll just rename this to actually B. Okay, and let's rename this to C so we have the correct terminology. So this should be 7.8, and then the angle from B1 to A to B should be 36 degrees. Okay, so that's what we have. Now on the other side, we have Bell's rope, which is 5.9 meters long. So what I'm going to do is I'm going to do a circle at point B with a radius of 5.9 meters. And here's Bell. Let's just say okay, so here's Bell, 5.9 meters away. Rename this to side A. Get rid of these circles so they're not adding so much extra information. And then we'll just draw a segment along the ground, A to B, A to C here. Oh, I see. Just rename this to point C. Okay, so segment A to C. And it seems they are 10.02 meters apart. Again, you could measure that angle is 51 degrees. We know how far apart they are down here. And I'll just get this to show the Okay, so not too bad, just doing something like that. So that's kind of like what the diagram looks like. Now let's see how you would solve this without the use of the computer. What we know, the sine law says the following thing. Sine A over A is sine B over B is sine C over C. Or alternatively, you can do all the reciprocals depending on what you need. A over sine A is B over sine B is C over sine C. In general, I would say use whichever, so if you are looking for, so whatever you need to find, put it on the top. E.g., if you're looking for a side, put all the sides on the top. If you're looking for an angle, put all the sines on the top. Okay? So whichever. Anyway, now to do this, what you do is you pull apart any two of these. So you don't use all three, you just use two, where you know three pieces of information. So let's write down what we know. We know that angle A is 36 degrees. We know that side C is 7.8 meters. We also know that side A is 5.9 meters, right? Those are the three things we know. So what we ultimately want to do here is get side B. The problem with side B is that if you put B over sine B right now, we don't know side B and we don't know the angle B. So we can't work with this because it's an unknown over another unknown, and that doesn't work. It doesn't work for now. Okay, so instead, what we're going to do, we're going to find angle C, and then we're going to say angle B is 180 minus A minus C, because we know that the three angles in the triangle have to add up to 180. So we're going to figure out what this angle down here would be, because the computer told us it was 50.99, but we're going to figure it out. And then we'll be able to use that to tell us what this should be, and then we can use that to tell us what that should be. Okay? So when you're working with the sine law, you're always working with a pair, A and A, or B and B, or C and C. Okay? So like that. Anyway, to do this, what we're going to do is we're going to start by actually finding the angle that goes with C. So I'm going to start with sine C divided by 7.8 equals sine A divided by 5.9. And we'll just move things around. We get sine C is 7.8 times sine A divided by 5.9. And we get C is equal to, so we're just going to go back here. And we'll go inverse sine 7.8 times sine A was 36 degrees. And divide that by 5.9. When we do that, we get 50.99 degrees, which is, let's just say 51. Okay, so close enough, 51. If that's true, then we know A plus B plus C equals 180. Therefore, 36 plus 51 plus B equals 180. And B must be, what would that be? Let's see, that's 87, so 93. B must be 93 degrees. Again, just to check my math for this. Let's go back here and measure A, B, C. 93.01, right, so 93 because we rounded. Now, if angle B is 93, right, then it stands to reason that side B divided by sine of 93 equals side A. Let's just go back to side A because we know those ones, which was 5.9 divided by sine of 36. So again, just using the sine law again to figure out the missing piece. And I determined that B is equal to 5.9 times sine 93 divided by sine 36. Yikes. Okay, and if we do that, so quickly 5.9 times sine 93. I should try not to round when I'm until I get to the final answer. So let's leave it as 0.01, and then divide by sine 36, and I get the answer 10.02. So b equals 10.02. Now that's great. Pretty straightforward. All I'm doing is using the sine law a couple times to, first I got to figure out something about the pair of b, either side b or angle b. I figured out angle b, and then I used the sine law to get side b. Everything's fine. Except it shouldn't be fine. My answer's right, but it's not finished, which seems strange because the question only said how far apart are the two people. It comes back to what happens in this step. And this is why I've been making such a big deal about your inverse sines here. Remember that when you inverse sine something, you get beta. You don't get theta. Let me demonstrate to you why this is important. Here's the picture again. So, sorry, it wasn't 38 degrees, it was 36. Let's put 36 degrees there. Okay. And here's Albert sitting at point A. He has a 36-degree incline, and his rope is 7.8. Now, first of all, it should be noted that not every triangle is actually solvable. Suppose the other person's rope had only been 4.3 meters instead of the 5.9 that it was. That rope actually couldn't reach the ground, right? So it's possible that the triangle that you're given doesn't exist. And of course, how that would appear in your answer, just for the sake of it, let's say we change this to 4.3 for. Actually, I'm not going to actually change it, but let's just do the math as though it was 4.3 for a second. So I'm going to go back to this where we did, and I'm going to divide it by a smaller length. Let's say her rope was only 4.3. That angle doesn't exist because you're trying to do inverse sine of a number that's bigger than 1, and you can't do that because there's no such thing as a number whose sine is bigger than 1, because sine is opposite over hypotenuse, and the opposite can never be bigger than the hypotenuse, right? So it's possible, first of all, that the triangle doesn't exist. But more interestingly, it's possible that the triangle we thought we drew isn't the only answer, right? You see, when her rope is 5.9, which is what we said, right? We assumed that she was standing over here. And that's why we got 51 degrees and 93 degrees. However, what if she was standing on the same side that Albert was standing on? She was just in front of him. And she still has a rope of exactly 5.9 that reaches the balloon. But this is an entirely different triangle, right? The one on the left. There's a really good diagram of this in your actual note we can look at. This, we just assumed, right, when we went through the question that she was on the opposite side. Because when we took inverse sine, we got 50 degrees, and we could draw it and whatever. But we don't know that that's where she is. Let's go back to the step where we couldn't have known, right, what we really should have done here. Let's go back to this step. So here, we come to the conclusion that C was 51 degrees. Now, the mistake here, let's say 50.99, just to keep it clear. The mistake here is this. Oh, I see. Okay. Okay, the mistake here is to say this. Sine C, so what we would say here is C equals inverse sine, right, of 7.8 sine A, which was 36, divided by 5.9. Okay, now whenever you hit inverse sine, there are two answers. There's a quadrant 1 answer and there's a quadrant 2 answer. When you do inverse sine, remember, it's either going to tell you beta, or if it gives you a negative number, what it's telling you is negative beta. So the correct thing to say here is actually that beta beta is 50.99, and your answer in quadrant 1 is that theta equals beta, and therefore your answer is theta equals 50.99 degrees. Your other possibility, however, is that theta is just making sure I get this right. Theta equals 180 minus beta. In this case, you take 180 and you subtract that 50.99, and you get, what would that be, 129.01 degrees. Now, if you plug in 129.01 instead of 50.99, okay, the answer is the same. Let's observe. 5.9 divided by sine 53.01. Sorry, it was 50. Was it 50? 50.99. I'm sorry. Okay. Now, exact same thing, except instead of 50.99 on the bottom, let's put 129.01. I guess I should actually keep them separate so we can actually show. How many times can I make this mistake? Okay, now what you're seeing here is that there are two answers that both work, that there's no way to know which one was right. There's no way to know based on what this question says. All it says is Albert's standing here and his rope is 7.8 and Bell's rope is 5.9. Bell's rope could point to the right. It could also point to the left. It's just as possible that it points this way. Now, if this is what would happen, how would the question be different? So what did we do from here? We said a plus b plus c is 180. So a plus b plus c equals 180. A didn't change. That was Albert's angle. B did change. Let's round it to 129. Well, we'll leave it actually 0.01. Plus c equals 180. In this version of the triangle, okay, c is 180 minus 129.01 minus 36, which is 14.99 degrees. And from here, right, from knowing what c is, I'm sorry, I used c. I shouldn't have. Because I was looking at their picture, but sorry. This should have been plus b. I apologize, just to make it consistent with the other one. Okay, from here, what we did was we used the sine law again. We said b over sine 93, so let's do the same thing. B over sine 14.99 is equal to a, which is 7.8 divided by sine 36. And you figure out that b is equal to, so let me just quickly do this. So 7.8 times sine 14.99 divided by sine 36. And you find that b could have also been 3.43 meters. Now, if I draw that on my picture, okay, so let's draw a point I0, and then we'll say segment EB. Now this segment sorry, I made a mistake there. I said 7.8 over 36. It's supposed to be 5.9 over 36 because the 5.9 side is across from the 36. Sorry, I for some reason I thought these two were connected. They're not. That's a mistake. Let's just go back to this now and with that fixed. So I typed 7.8. I should have typed 5.9. And then I find that it's 2.596. So let's say 2.6 meters apart. So back to here. Okay, 2.6 meters apart. Now, if you draw that segment, okay, so here it is. Here's the segment. They're 2.6 meters apart. Okay, that if you measure from this point E to this point B, you get 5.9. So there's no reason that she couldn't be standing here instead of standing there. And given based on the information in the question, it's not possible to know, and this is why we call this the ambiguous case. Ambiguous means it's you can't tell. It's unclear how to tell. Okay? So let's just make some room here and read what it says about the ambiguous case here. Okay, well, wouldn't be the first time I didn't know what this program is doing. The ambiguous case arises only in this specific circumstance. Okay, this does not, most of the time when you are doing a triangle and you do inverse sine, you can just take what your calculator says. However, you should consider that whenever you press the inverse sine button, just like whenever you press the square root button, your calculator is giving you information about beta, which may or may not actually be the angle you're looking for. However, in every other type of triangle, as we will see later, this will not come up. And I'll give you some pointers on how to avoid this problem in other triangles. But in a side-side angle triangle, that is to say when you know two sides but you don't know the angle in between them, you know one of the angles off to this side. And if you just think back to what we knew in our question, let me just, it's easier if I use this one. What we knew this side, right, the 7.8, we knew the 5.9, and we knew an angle that was not in between them, which was the 36 degrees over here. In that case, it is possible you have two triangles, okay, and that's the case you have to be careful of. So make sure you have this with you when you're, doing your test or your assignment or whatever. The sine law calculation may lead to zero triangles, as I tried to show you here. It's possible that the other rope is like not long enough to even make a triangle, period. Okay, it's possible there'll be no solutions. It's possible there will be exactly one solution if the triangle is a right angle. Okay, it's also possible that there will be two solutions, or again, if this side is so big, it goes back down to just one solution. So here are the rules for how you could figure this out. Imagine you have a dotted line at the end. So here's A, so Albert again, right? We know the ground is here, but we don't know how far along the ground we're going, so we draw it as a dashed line. We do know how far we're going in this direction, and we know how far we're going in A's direction, right? But we don't know any other angles. So if you imagine that it's a right triangle, then B times sine capital A would give you this height, which means if the little a here is shorter than B sine A, you can't get a triangle, which as you can observe here. B sine A is bigger than little side a, so you cannot form a triangle. You try to do this, you try to do sine b equals 1.066, and you can't do that because, as I said before, you can't inverse sine a number bigger than 1. So if it is equal to exactly b sine a, then you get a right triangle. If it's greater than b sine a, okay, then you have two answers. And if it's greater than b, you only have one answer because now you don't, it's like the second one is imaginary, right? So if it's greater than b, if it's bigger than your other side, if her rope was longer than Albert's rope, then you wouldn't be able to make another one with her over here because now his angle would change. Okay, so this is kind of like this really nicely demonstrates this. If A is less than B sine A, you don't have a triangle. There are zero solutions. If A is equal to H, okay, there's only one triangle because it's a right triangle. If A is greater than B, there's only one triangle because the second one would be point over here and would change B's angle. But if A is in between B sine A and B, you have two triangles. And this is the one that's tricky, that you got to be really careful about. Notice in all of these questions, angle A has to be acute to even consider this, because if angle A is obtuse, then it doesn't matter, right? There's only one triangle you could make ever. You can never make a second triangle because one of the angles is already obtuse, and therefore the other two angles are acute, and you can't get the quadrant 2 answer. So it only happens if the angle you know is acute and the other side, is less than B, so it has to be less than 7.8, but it has to be bigger than B sine A. Okay, so it has to be in that sort of range. Again, if A is obtuse and A is less than B or equal to B, there's no triangle. If A is obtuse and A is bigger than B, then you have one triangle. Okay, this piece of paper is really important. Go over it, study it, draw it out, right? Learn what this is saying. Let's try a couple of the questions. I'm going to do a couple and I'll leave a couple, I think, for today. It says, determine the number of possible triangles that could be drawn, then draw and label. So why don't I do the number of triangles for each, and I'll draw and label one of them. So again, let's do the analysis. What do we know? Angle A is 50 degrees. Side A is 9. Side B is 8. Now, what if you draw this? So again, let's just quickly draw what we know. Okay, so angle A is 50 degrees, side B is 8, and A is 9. So I'm going to draw A is located at 0, 0. B is located at rotate 8, 0. How far was it supposed to be? 50? So B was length 8, and it was 50. Oh, I see. 50 degrees, but I typed that in wrong, so. Okay, so there's point B. Again, if I do a segment from A to B, it's exactly 8 units long. If I go angle 1, 0, so if we measure the angle in standard position, the angle's 50 degrees. So everything's perfect here for my drawing, right? I should really rename this to C just to make it make more sense. Now, the other side is side B. Now, I don't know where side B is, but I know if I draw a circle point B with radius 7, right? Sorry, A is 9 and B is 8. I'm sorry, I'm just drawing the wrong thing here. Sorry, I see what I've done wrong. This should be point C. This should be segment B, which is 8, and then this one should be 9. Okay, so the circle, okay, so again, this is a good example. The circle here has a radius of 9. Now, you can see that if you were to try to draw this triangle over here, right, you can't do that because you just messed up angle A. Angle A is not in the triangle anymore. Now it's 130 degrees, right? It's over here. So you can't draw the triangle that exists over there. You could only draw the triangle that exists over here. Right? So let's delete this. And you'd have to draw this triangle here. Okay, so let's draw a segment from D to C, and let's just get all the naming done properly. So rename to B, and F should be renamed to A, and G should be renamed to C. Okay, so let's get rid of the circle, and let's get all the values to show. Name and value. Okay, and then let's get all the angles to show. I'm going to rename those angles quickly. So let's rename angle beta to angle C. Actually, we can hide the points, I suppose. And then angle alpha, we're going to rename to A. And angle gamma, we're going to rename to B. Okay, so here's what you got. So let's just confirm what we've done with what they asked. Oops. Okay. Here, only one triangle can be formed here since A is greater than B. Right? The A side, it's bigger than the B side. So there's no way you could draw a second triangle here. Again, let's just one more demonstration here. Let's make alpha 50 degrees. This side was side A was 9 and side B was 8. Okay? There's only the one triangle you can get. It's bigger than B sine A, but it's also just bigger than B. And when it gets bigger than B, there's only the one triangle, since A is greater than B. Okay, in your box here, this would be this box here. Okay, so again, how you would solve this one, you would just do the sine law. Okay, so I'm not going to do it because I did it already, but you would basically follow the exact same steps that we used to solve the first time we did this triangle. So you can go back to that if you want to review how to do that. Okay. Now the next one. Okay. Again, it gives us angle A, and B. So let's make a comparison. Let's do B times sine A. What is B times sine A here? Okay, because this time A is not bigger than B. You can see here A was bigger than B. That makes the question easy. There's only one triangle. It's finished. Here, let's do B sine A, because that's really the thing you need to compare. So if I do B, which is 17.2 times sine A, I wonder if I could just quickly reorganize this to... Oh, it doesn't matter. Okay, sorry. So B times, 17.2 times sine 37, I get 10.35. Now, I make a comparison. Compare A with B sine A. Okay. In this case, we find out that A, which is 9, is less than 10.35. Therefore, A is less than B sine A. Therefore, no triangle can be formed. Right? And we can easily demonstrate that back here. Go back to this. We'll set B to 17.2. Okay, 17.2. We set the angle to 37 degrees. And we check A as 9. Not long enough, right? Doesn't reach to be able to make a triangle. A would need to be, what the number we found, 10.35, right? And actually even slightly more than this, because of course I rounded it. You can see I'm still slightly off. It would need to be 10.35, so 10.36 should be big enough, right? Slightly big enough. So this is too short, and this is a really easy question. As long as you know your formula, you show me this, you say no triangle can be formed. There's nothing you can draw, so you can't really label it. Okay? The last one is going to be the ambiguous case. So we're going to find, well, I assume anyway, B sine A. You always start with B sine A in these questions, so let's do that. So B was 9.2 sine 34. Oh boy, sorry. and we get 5.14. Now, A, okay, B sine A is less than A, and A is less than B, right? Because 5.14 is less than 7.1, which is less than 9.2. Therefore, we have the ambiguous case. Again, I've shown you how to do this. I think this is really just practice. So what I'm going to do is I'll post the answer here, and you can, you show me on the discussion forum how to do it, or if you have a question, how to do it. But basically, do the sine law as though you were going through it normally. But remember, when you do the inverse sine, you have to consider two answers. Anyway, let's type in what we know here. So alpha is 34 degrees. The parameter A is 7.1. And the parameter B, so B parameter, is 9.2. Okay, now if you do this, I'm just going to get rid of the circle just to hopefully make this a little bit easier to show. Okay, these are the two answers you should get. I don't recommend drawing the two triangles on top of each other like this, by the way. It's just how I'm going to do it. But you can just draw two separate triangles. So I'll give you, here are the answers. So you have the answers to check. Again, the method is what we did up here in the box. So the left side of the box, as soon as you get to inverse sine, your question splits into two. You finish it as though it were an acute angle, and then you finish it as though it were an obtuse angle, and then you're done. Okay, so anyway, I give you the answers there, and that's that. Okay, the distance between points M and K is 9.14. Calculate the height and the horizontal distance L to the nearest hundredth of a meter. Alright, so again, just looking in our triangle, angle K inside the triangle would be 180 minus 49, which would be, what would that be, 131? Okay, so the angle K that's actually inside the triangle would be 131. Therefore, angle L inside the triangle would be, what would that be, 38 plus 131 is 169. So you need another 11 degrees to get to 180, right? Now, we know the three sides inside the triangle, and we know that the bottom side is 9.14. Therefore, what we could say, we'll just do this properly so you can see kind of what I'm talking about. So, again, forget this thing on the outside here for a second, and let's just work on the small triangles. Okay, so small triangle M L K. Okay, so angles, sides. Okay, angle M is 38 degrees. Angle L is 11 degrees. And angle K is 131 degrees. Again, whenever you're doing this work, it's always helpful to just do a quick check of what you've done. 38 plus 11 plus 131 gives me 180, so that's pretty good. Now I know side L is 9.14. I don't know any of the other sides. So what I'm going to do is, what I would be interested in knowing, right? I'd be interested in knowing either of them. But I think particularly I would be interested in knowing side M. And the reason is because if I know side M, then if I look inside this right triangle, I have a 90 degree, I have the hypotenuse, and I have 49, and I can easily get the height from there. You could do it with the other one for that matter too. They both should give you the same answer, so it actually really doesn't matter. Let's work with side M. M over sine 38 is equal to L, which would be 9.14, divided by sine 11. Okay, and therefore you get the answer that M is equal to, again, you just kind of multiply the sine 38 over here and get the answer. So let's do that. So 9.14 times sine 38 divided by sine 11, get 29.49. Now again, try not to round in these questions until you're done. It would actually be better of me to keep 4 decimals as I'm working. Okay. Keep 4 decimals as I'm working, so 491, and then I can round at the end. Okay? Now, if this is true, I also know in the right triangle, okay, M is the hypotenuse, H is the opposite, and 49 is the angle. So I'm just going to write sine 49 is equal to H over 29.491, and therefore H equals sine 49 times 29.491, and that would be H 22.2571. And now you're good to go ahead and round it, and you can say 22.3 meters. Okay? To the nearest, it says your nearest hundredth, so sorry, it should be 22.26. Okay, and that would be that one. Let me make a quick diagram. I'll pause it and make a quick diagram and paste it. Just a second. Okay, so the diagram again, it just looks something like this. So, I had it measure the 2 angles in the bottom. Found the 2 lengths. We only needed to find one, of course, in the question, and we never needed to find L, but I'll put it here because, of course, there are many different ways you can do this one. So, anyway, as a final answer, 22.26 is what you would get to the nearest hundredth. Notice this is not actually a ambiguous case question, right? There's only one answer and one way to do this, so you don't have to consider a second one. Now this last one is an ambiguous case question. It says the light from a rotating offshore beacon can illuminate to a distance of 250 meters. From a point on the shore that's 500 meters from the beacon, the sight line to the beacon makes an angle of 20 with the shoreline. So here's the picture. So here's the point on the shoreline. You're 500 meters away from the beacon. You have a 20-degree angle between the shore and the beacon. And you know that the beacon can illuminate 250 meters. So it could be 250 meters this way, or it could be 250 meters towards you, right? So let's go ahead and work on this question. So we know that, let's define the point where we are equals A. That means lowercase a is 250 because the 250 would be the side, the light that's being emitted from the beacon. Okay, so again, one triangle, it will point over in this direction. One triangle will point towards us. But in either case, A is 250. We'll define B to be the distance to the lighthouse, which is 500, and then we'll do our usual thing. B sine A. What is B sine A here? 500 times sine of 20, which is how much? So, okay, so 500 times sine 20, 171.01. Now, B sine A is less than A, which is less than B, right? So let's just write it again. B sine A is less than A, less than B. Therefore, there are 2 triangles to consider when the light points away from us and when it points towards us. Okay. So again, let's do the calculation. So what we would be trying to do here is we want to say something like sine B over B equals sine A over A. Okay, so we go sine B over 500 equals sine A, which is 20, divided by 250. Okay, so what we come to the conclusion here is that sine B is equal to 500 over 250 times sine 20. And this kind of simplifies nice and easy, right? So we can just simplify it to sine B is equal to 2 sine 20. because of course 500 and 250, you know, to deal with pretty well. So let's go, what's 2 times sine 20? Okay, so 2 times sine 20, we get 0.68. It's not really good enough for what we're doing, so let's keep more decimals. 0.68404. Now at this point, to find the angle that has this sine ratio, we use the inverse sine button. However, we do not know whether the angle we're looking for is in Q1 or Q2. So we proceed along 2 different paths. We do the sine inverse of 0.68404, but when we get that angle, we remind ourselves that that is beta. Okay? Then we say there are 2 answers. Case 1, where you're in quadrant 1. Okay? In this case, theta equals beta. So pretty easy, just the way you would normally do the question. Case 2, you're in quadrant 2 because your angle's obtuse, and you end up with theta is 180 degrees minus whatever it is the calculator tells us. So let's go ahead and use the calculator to figure out the inverse sine of 0.68404. So inverse sine of b. It gives me 43.160. Okay, so when I do this, I get beta 43.160 degrees. Okay, now in this case, this is easy. All I write is that angle B is 43.16 degrees. And I just keep doing the question that way. Okay, this case, all I have to do is remind myself that angle B is actually 180 minus 43.16 degrees. And so I keep doing the question as though, let me just quickly do 180 minus gamma. 180 degrees minus gamma, maybe? 136.84. So all I have to do is I just keep doing the question as though each of these were the next step. The next step here is to then say, okay, I know what A is 20, B is 43.16. What's C? Okay, so C, of course, would be 180 minus 20 minus 43.16. C would be, so 180 degrees minus 20 minus gamma minus 20 degrees. It's very picky about this. 116.84. So that's one possibility. The other possibility would be A is 20, B is 136.84. What's C? Here, C would be 180 minus 20 minus 136.84. And in this case, C would just be, I actually don't know what that symbol is. I'll just type it. 23.16. Okay, so those are my possibilities. Now, in this case, right? So let's finish the triangle this way, and then we'll come to a conclusion about the final answer. So we go C over sine C equals A over sine A, which was 250 divided by sine 20. Okay, and so we get the conclusion C is equal to 250 times sine 116.84 divided by sine 20. Oops. Okay, and if we finish that off, so 250 times sine 116.84 divided by sine 20. 652.206. So remember, what was point C? So the farthest the lighthouse can illuminate is a point 652.206 meters away from point A, okay, along the shore. Right, because look back at the picture. What did we just find? We just found that if the beacon's light is pointed out this way, then you would be 652 meters away along the shore. Let's finish the question this way. Same thing though. C over sine 23.16 equals 250 over sine 20. Okay, so therefore C is equal to 250 sine 23.16 divided by sine 20. Okay, and in this case, okay, so let's just quickly find out what that is. So again, just calculating here. 250 times sine 23.16 divided by sine 20, 287.48. What does this mean? The closest point the lighthouse can illuminate is a point 287.48 meters away from point A along the shore. So, to reread the question, what length of shoreline is illuminated? Well, therefore, the lighthouse can illuminate anywhere from 278.48 to 625.206, and it can illuminate, and we'll just subtract those two, so E minus K, 364.72 meters of shore. Again, I'm going to draw, I'll do a diagram here. Let's use my GeoGebra app to do the diagram. Okay, so of course I can't use 250, so I'm just going to use 25. So we'll just factor it all down by a factor of 10. We know that the beacon was 50 units away. Oh, I see, it actually can't. Okay, so we're going to have to factor it down by 100. So let's use 5 and 2.5. Okay. Now we know that the angle was 20 degrees. Okay, and let's look at the two solutions. Make this a bit bigger so we can. Okay, can I? Sorry, I see. Stretch it that way. It doesn't really matter. Okay. So that's probably about as big as I can get it. Okay, so look at what it says. Let's put the circle back on. The lighthouse illuminates in a circle with a radius of 250. It's a spinning light that spins around this 250 meter radius. It contacts the shore, right? As it's rotating, it does not contact the shore until this moment. And this moment, as you can see, is 652 meters away from where we are standing. It then illuminates the shore all the way up until this point, which is 287 meters away from where we're standing, and then it no longer illuminates the shore because it's rotating out towards the water. Okay? So the solution is simply this one subtract that one. And again, I'm just going to write, I'm going to just take a picture of the whole thing. And the solution is, of course, to subtract the two. Okay, and so there you go. Really good question. There's one in the assignment very similar to it. Try it. See if you can do it. Okay, so today, really heavy on the concept. Very difficult concept. Okay, but actually mathematically, it is not too bad as long as you just remember this one key thing. When you inverse sine, the calculator is trying to tell you two answers. So unless you already know in advance that your angle is acute then you have to consider this other option. Okay? But if you do know that the angle is, acute, then you don't have to bother. You can just do the one answer. Okay? So try some of these ones. Again, post questions. I'm happy to try to help.